Dear students, a very good morning to all of you. I welcome you all to this session of information security. In this session, we will learn about what is encryption and decryption. We will also define the model for the network security, and we will also go through the symmetric cipher model, which is used in conventional encryption. Although it is obsolete nowadays, but still we must know what is metric cipher model before using the asymmetric techniques. Then we will learn about the types of encryption, then symmetric encryption types. Then we will also learn the various substitution techniques of symmetric encryption. So first slide, the encryption is the process to convert the plain text into the ciphertext. Plain text is human readable text, and ciphertext is the decoded form of the plain text, and this is called encryption. And when the encrypted text is passed over the transmission channel over the internet, so that any opponent or any hacker could not read this information or could not figure out the information, for that we send the information in the ciphered form. Then the decryption algorithm on the receiver side will receive this ciphertext and will decrypt this or decode this algorithm, decode the ciphertext using the decryption algorithm to the plain text. And this process is called decryption. That means the process of converting plain text into the ciphertext using some secret information is called encryption. And the reverse of it, that is decoding the ciphertext into the plain text, which is sent by the sender using the shared key or any secret information, that is called decryption. I repeat, the process of converting plain text into the ciphertext. Ciphertext is a decoded form which may not be read by the hacker or the opponent on the transmission channel on the internet. So for that, we perform some mathematical calculation on the plain text to convert it into the ciphertext, right? And the mathematical calculations which we do are generally in the form of algorithms, and they are known as encryption algorithms or secret information algorithms or transformations. Then the reverse of it, the decryption algorithm on the receiver side will receive the ciphertext from the sender, and it will use the same algorithm which was used for encryption to decode the ciphertext into the plain text, and this process is called decryption. Now this is the security model which I have also drawn on the board. See, there is a message which is to be sent by the sender, and secret information is the key space or the number of there are number of keys which is used to secure the information. And after securing the information, the message becomes secure and it is passed on the information channel. Then the secure message is received by the receiver. He will deploy the decryption algorithm using the same secret information which is being shared and pass the message or decode the message or decode the ciphertext into the plain text. Suppose there is some dispute regarding the secret information between the two parties. Maybe the sender has used some different key or receiver has used some different key in order to retrieve the text, and the recipient is not able to figure out the exact text. So it may consult the third party, which is responsible for resolving all the conflicts between the sender and receiver regarding the shared key. All the disputes between the sender and the receiver regarding the keys or the shared information which is used to secure the information or the message which is sent by the sender. Fine. So why do we actually secure the information? There might be some opponent, as you can see the diagram. There is an opponent or a hacker which is there who can actually try to capture this ciphertext, because ciphertext is normally meant public, and the person, the hacker or the opponent has the direct access to this ciphertext. And when he captures this ciphertext, then he has then he may try to guess key or the plain text, anything, if he has some knowledge, then he may be able to guess the plain text, what is being sent. So we usually use the larger keys in order to secure the information so that that should not be actually hacked by the hacker or may not be captured by the hacker. So I'll tell you the different steps what we are performing. See, this is my network security model. Already told you that there is a message which is generated by the sender. Then secret information like key is applied on this message to generate the secret message. Then this message is passed over the information channel that is on the internet in a secured manner. Once the message is secret message sent over the information channel, it becomes a secure message since it was encrypted using some key. Then the same secret information or key is used to decrypt this secure message into the plain message. So secure message would be in the form of ciphertext, and the receiver will apply the decryption algorithm or the keys to get the plain text back at this side, that is at the receiver side. This is receiver side and this is your sender side. Fine. So sender is sending the message along with the key, and the encryption algorithm is used to secure the algorithm using some key and convert it into the secret message. Then this message is passed over the information channel. Then this message gets the secure message and it is in the form of ciphertext. And ciphertext message is being decrypted by the decryption algorithm and the key which is being shared by the sender to the receiver, and it will retrieve the plain text back. Fine. That is, the information is being sent by the sender. Then the secret key or the encryption algorithm is applied here. Encryption algorithm is applied here. The algorithm which is used to convert the plain text into the ciphertext is called encryption algorithm. Along with the key is there to generate the secret message. Then we need to send the secret message over the information channel so that it should not be captured by any hacker, or any hacker should not be able to read whatever the message is being sent by the sender to the receiver. Then it will become secure message. Then you will apply the decryption algorithm. We will apply the decryption algorithm and the key which is used to decrypt the original message into the, the ciphertext message into the plain text, and it will be able to retrieve. Now, what does it have? See, first of all, the sender and the receiver, they should follow some protocol, or they should actually agree upon the common protocol that how the transmission will take place between the sender and the receiver. Right? Secondly, sender will agree with the receiver to send the ciphertext message along with the codes to verify the authenticity of the sender. That means receiver will come to know that actually it is the sender who is sending the code, sending the message. Then the message is being passed over the information channel. Fine. So here the codes are also checked in order to identify that the source is the original sender. Fine. And secret key is also shared so that it will be received by the receiver, and using the secret key it will be able to decrypt the message which was being sent by the sender. So for this network security protocol, we have to follow these steps. First of all, design an algorithm. Design an algorithm both for encryption and the reverse of it will be for the decryption. Then general secret information, the secret codes which we are sending along with the ciphertext. Then develop the method for sharing and distribution of key. What does this mean now? So you will generate the secret information which is to be shared among the sender and the receiver. Then develop the method for sharing and distribution of key. Supposingly you are sending the key and the ciphertext over this information channel which is on the internet. That means there are many chances that your analyst, that is hacker or opponent who has the knowledge of the ciphertext and the key, fine, he will be able to guess the plain text. So there should be different mechanism for sharing the keys between the sender and receiver. So it may be done through the third party, which can share the key privately or securely among the sender and the receiver. It should securely transmit the keys or distribute the key to the sender and the receiver. So it could be done by the trusted third party, which is trusted by both sender and the receiver. So dwell the methods for sharing and distribution of key. Then we have to specify a protocol. Protocol is nothing but the rules and the regulation which are being followed by sender and the receiver to send and receive the messages. Both the involving parties will be agreeing on the same protocol in order to transmit the data, because one time the sender is sending to the receiver, another time receiver may send to the sender, because this is two-way communication, so they will follow the same protocol. Now this is the plain text, then this is the encryption part, encryption algorithm, and this is the key which is to be sent, transmitted text, then decryption along with the key. Then we have plain text, see, this is a plain text which is in the form of X, applying encryption algorithm and key. Supposingly we have applied AES algorithm on this text, so it will generate the encrypted text, that is Y, which is equal to encryption of K comma X. Actually, we have performed the encryption over the plain text X using K key, using key K. So the output of it will be Y, which is equal to ciphertext, right? CT stands for ciphertext and PT stands for plain text. That means Y is equal to E of K comma X. So X is your plain text and it is encrypted using the key K, and it will generate the ciphertext, which is received by the decryption algorithm on the receiver side, and it will also get the key. So X means how the plain text will be recovered using the decryption algorithm. So this is decryption algorithm, and using the key and using the ciphertext. Applying the key on the ciphertext, you will get the plain text which is equal to X. Decryption algorithm will make use of key as well as the ciphertext to recover the plain text back. See, this is symmetric cipher model, which I have mentioned in the outline. So this is what we have done. See, the plain text is an original intelligible method or data which is fed into algorithm as input. We give the plain text as input to the encryption algorithm. Then it performs the various substitution and transformations on the plain text, or it apply some mathematical functions in order to convert the plain text into the not readable form or not non-intelligible form. Fine. Intelligible form is the form which is being read by any person. So secret key is also the input. As you can see, the yellow secret key which is there. Secret key shared by sender and receiver. This is the key which is being, shared by sender and receiver both. So the key value is independent of the text which is being fed to the algorithm. The algorithm will produce a different output depending upon the key which is being used at that particular time. Now, transmitted is the ciphertext, which is a scrambled or unreadable message which is produced as the output, and it will depend upon the plain text and the secret key. The encryption algorithm will take the key to convert the plain text into the ciphertext. Although ciphertext is not, which is being fed to the encryption algorithm, is not dependent on the key, but encryption algorithm will use the key to convert it into the ciphertext. So the ciphertext is apparently random stream of data, and it stands as unintelligible, means it will not be readable. Now, the decryption algorithm is essentially the algorithm which run in the reverse, and it is usually at the receiver side. It takes the ciphertext and secret key as the input and converted it into the original plain text. So this is how, this is block diagram, you can say. An opponent means cryptanalyst or the hacker, one and the same thing. Cryptanalyst is the person who actually have the knowledge of decoding signs. That means he is the person who is there, who takes the ciphertext as an input and try to recover the plain text or guessing the key. Fine. So message source is X and it is plain text. That is X is being fed to the encryption algorithm, and using the key it is encrypted and it is passed to the secure channel to the decryption algorithm. But cryptanalyst has the direct access to this encrypted data, that is Y. Fine. So opponent observing Y but not having the access to K or X may attempt to recover X or K or both K and X. If he has the key, he can recover, he will try to recover X. But if he has X, he will try to recover the key. What is the key which is being used to convert this plain text into the ciphertext? So if the opponent is interested in only this particular message, then he will be able to recover. He will try to recover X by generating the general estimate, that is of plain text X. Fine. However, the opponent is interested to read the future messages, whichever the communication will be going in the future as well, then he will try to recover the K. Means if for this particular message he is interested, then he will try to just guess the message only, estimate the message which is being sent by the sender to the receiver using his own mathematical techniques. Wherever if he is interested in the future communications which is taking place between the sender and the receiver, he will try to recover the key. So what are various types of encryption? There are two types of encryption, symmetric and asymmetric encryption. Here you are seeing Alice is want to send some data to B. When the common key is shared between the sender and the receiver, that is called symmetric key encryption. Whenever single key is being transmitted or single key is used both for encryption and for decryption, that is called symmetric encryption. Symmetric means same. So same key is followed by the sender and the receiver as well as to encrypt the message as well as to decrypt the message. So as you can see, it is written in symmetric key cryptography, the same key is used by the sender and the receiver, that is for encryption and decryption process, and the key is shared. So these are the algorithm DES and 3DES which we'll be doing in the future classes. So symmetric key cryptography advantages, it is very simple and faster. And disadvantages, key must exchange in a secure way, because if you are sending the same key, if it will be hacked by the opponent, he will get easy access to your messages which are being sent. Then you have the asymmetric key in cryptography. First of all, I like to give you an example of symmetric key, then we will come to this asymmetric in cryptography. I just want to give an example of symmetric key encryption. So right now we have some text in network security. Whenever we are sending some text, it is in the character form, and E, F, G, H, I, J, K, L, M. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I just take an example. Suppose this is the text I want to send DEF. I want to send some text, or hi, I want to send. Right? I want to send hi to some person, and I send the key +5, +4. Right? So H is at the 7th position. H is at the 7th position. Then +4, 1, 2, 3, 4th letter you will pick L. Then for I +4 will be, I is at the 8th position. 8 +4 is 12. So you will pick the letter at the 12th position. So this will be LM. So this is my plain text. This is my key which is shared or symmetric key, and this is my ciphertext. Now I will transmit this LM over the transmission channel to the receiver. Now receiver, what do the receiver will get? It will get this secured message LM, and it will get key, that is 4. So he knows that it was +4 in the beginning, so it is going to decrypt it. So the reverse of it is -4. So 12 minus 4 is I, that is M is at the 12. 12 minus 4 is 8. So at 8th position, we have alphabet I. Now for L, it is 11. L is at 11, -4 will be at 7th position. So this is called I. Now you see single letter 4 is being shared. Single number 4 is being shared, and it is your key. Now what happens when the opponent has access to this number 4? Definitely he will try to guess, because he knows the various techniques how to decode the text. So it will apply +4 or -4, and he will be able to get the, he will be able to get the plain text. So this was your ciphertext, this was your key, and this is your plain text. So this process is called decryption, and this is called encryption. Okay, so this is encryption and this is decryption. And the opponent can have easy access if the key is not sent in the secured manner. Suppose the key is being sent in a secure manner, then he may guess, but he may not be able to retrieve. So usually it is recommended not to use the single number, but to use the larger space, so that it should be difficult. Because if I say, see, suppose if I say 1,000, the key space would be, actually there is one attack called brute force attack. Brute force attack means trying all the possibilities. So the hacker will start from number 1 till number 1,000. His key space will be large. His key space would be large. Then what happens is, what is the benefit of having this key space large? Actually, the hacker will put in much more effort and much more time to recover the key. And by that time, the useful information lifetime may be over. Means it could have been received by the receiver, and it is of no more use to any sender or any receiver, because it has read the message, make the use of it, and it's okay now, because it may be read by the receiver, may be read by the opponent. It may not be of any harm to the receiver. So that means the lifetime of that information may be expired by the time the hacker tries to retrieve or retrieve the key and then apply on the ciphertext to retrieve the plain text. So that is why large key spaces are recommended. Now asymmetric encryption. Asymmetric encryption means the encryption, it has two keys. Asymmetric encryption has two keys. One is public, another is private. Using the public key, the encryption is done. And the data is passed over the information channel. Then the receiver will use its own private key, to decrypt the message. Use its own private key to decrypt the message. That means asymmetric key exchange makes the use of two keys. One is public key, another is private key. Now, if public key is being passed over the internet, the hacker will try to guess only the private key, but he may not be able because private key is the private or it is secretive to the receiver. He will use his own private key to get the access to the plain text. So as you can see in the diagram, Alice is the sender, plain text, it is encrypted, see using the public key to the public. Now, Bob uses his own private key in order to decrypt the ciphertext into the plain text. So asymmetric key means makes uses of two keys. One is public key, another is private key. Or private key to encrypt the data, or public key to decrypt the data, or maybe reverse. Public key to encrypt the data is there, and private key to decrypt the data. So asymmetric, two different keys are used. So users get the keys from the certificate authority. I told you what is certificate authority. That is the third party which authenticates both the sender and the receiver. And the key will be shared by the third party, and it will give the certificate for the keys to be exchanged. The advantages are it is more secured and authenticated, and disadvantages, it is relatively complex for person to decrypt the messages. Now comparison, you can see there is one single key which is of black color in specific cryptography. Plain text is encrypted using the shared key, and ciphertext is sent to the receiver where it is being decrypted by the decryption algorithm using the same key, and Bob will retrieve the plain text. And in the second diagram, you can see the two keys, that is pink key and the black key. So pink key is the key which is used to encrypt the data, whereas Bob uses its own private key to decrypt the data. So see, asymmetric key uses two keys, one of to encrypt, another to decrypt. These keys are generated together. One is named as public key and is distributed freely. The other is named as private key and it is kept as hidden. Both sender and recipient has to share its public key for the encryption and use the private key for the decryption. So this is how it works. Give you a public key to the sender, then sender uses your public key to encrypt the plain text, then give you the ciphertext, and ciphertext will be decrypted using the private key. So see, this is the example which I picked from the internet. This is a ciphertext which is there for plain text hello world, and this, see, the hello world is the word which comprises of how many letters? 1, 2, 3, 4, 5. 11 letters are there. 10 letters are there. And for that, the ciphertext is too big. So that means it will be very difficult for the opponent or the hacker to analyze this to convert this ciphertext into the plain text, and it is done using the RSA algorithm, which you also have read in the computer networks. So symmetric key encryption types are of two types. One is substitution and second is transposition. Right? Substitution means you substitute different letters in place of other letters to convert, just like we did in the example of symmetric key encryption. That is called substitution. When you are replacing one, characters by other characters, that is called substitution technique. And when you rearrange the characters or the numbers so that text gets scrambled, that is called transposition. So I told you there are basically two classical encryption techniques. One is substitution, another is transposition. So substitution technique is one in which the letter of plain text are replaced by other letters, numbers, or any symbols. So that is called substitution technique. So you have monoalphabetic ciphers. These are basically the types of substitution technique which we will be doing. First is Caesar cipher, then monoalphabetic cipher, Playfair cipher, Hill cipher, polyalphabetic ciphers, and one-time padding. Before going to the Caesar cipher, I'll do the monoalphabetic and polyalphabetic. Then we will move to the Caesar cipher. See, in monoalphabetic substitution, there is a relation between the alphabets in one-to-one form. For example, the plain text is my name, and this is your cipher. Suppose n, this is m is encrypted as n. So wherever any m is occurring, it will be replaced by n. See, m is there, so it was replaced by n, and m is there, it will be replaced by n. Fine. So that means if we have decided that n will remain the ciphertext for the alphabet m, then wherever n is occurring in your text, it will be replaced by n itself only. So this is called monoalphabetic cipher or monoalphabetic substitution. Then we have polyalphabetic means polyalphabetic. See, monoalphabetic are very simple and they are easy to guess, because if you have guessed the one alphabet as right one, then the entire text, wherever that occurrence is there, you may substitute the text and you'll be able to retrieve the original text. So polyalphabetic means if my name is there, now see how many occurrences of M are there. There are two occurrences. First, it was the ciphertext for M was N, and for the second occurrence, it will not be N, it will be O, or you may say Z. Any other alphabet which will be not similar to the first character which is appearing as a ciphertext for the given M. So M is at location number 1, 2, 3, 4, and 5. So M is occurring at 0 and M is occurring at 4. So for 0th location, the text would be different, the alphabet would be different. And for the location number 4, the alphabet would be entirely different from whatever it is 0. For example, you have taken here N, you may take Z here, or you may take X here, that is up to you. Okay, for different alphabets, for the multiple occurrences of the same alphabets, you have different alphabets, different numbers to be substituted every time. So it will be difficult for the opponent or the hacker to guess this text and retrieve the original text. Now comes the Caesar cipher. Caesar ciphers are also known as shift ciphers, and they were proposed by the Julius Caesar. They were proposed by the Julius Caesar. So they are also known as additive ciphers. They are also known as shift ciphers, additive ciphers, and they were proposed by Julius Caesar. So he used this code, Caesar shift ciphers, to communicate with his officers, so that the persons who are sitting in his office should not know the communication, whatever is going between Julius Caesar and his immediate bosses. Fine. So he don't want to reveal the communication which is being carried on between the officers and him. So he uses shift ciphers. And in this, the key is being edited as you add the key to the given text in order to get the cipher text. That means, so each letter in the plain text is replaced by the key which is basically used which is basically used to perform the number of shifts. Perform the number of shifts, that is, for example, I told you that ABC just we have done high was shifted by 4 positions. So H was converted to L and I was converted to M. So plus 4 is nothing. It is additive, or it makes the that number of that position shifts where you can fetch the other alphabet which is substituted for this given plain text. Fine. So this is called Caesar cipher. Now we have the algo. Normally, Julius Caesar uses plus 3 as a key for the communication, 3 as a key for the communication with his officers. He normally shifts the words by using 3 and communicate with his officers. Now next, see, these are the algorithm. Caesar cipher is an algorithm which makes the use of following formulas. First is you will write C. Ciphertext is equal to encryption will be carried on using K plus P. That is, P is my plain text and K is my key mod 26. P is my plain text and K is my key, and ciphertext will be C is equal to ciphertext. So you will get the ciphertext using the plain text plus key. For example, if I write encryption 3 plus P plus 3 mod 26. So this is the formula which we will use to retrieve the ciphertext from the given plain text. Now, how plain text will be decrypted back? So you will write P is for plain text, D is for decryption. Then ciphertext minus key, C minus K mod 26 again. Fine. C minus K mod 26 again. So that will be equal to C is your ciphertext, and C minus C, if we are giving plus 3 here will be minus C and mod 26 it will be there. Okay. Now we will have looked at the example of it. We'll take some example here and you will look at the example which is there on your PPT screen. So in Caesar cipher, we always start A from 0 and it will continue till 25 because there are 26 alphabets which are there. So starting from 0 index till Z, there are total of 26 alphabet ranging from index 0 to 25. As you can see on your PPT, there are 0 to 25 alphabets which are numbered. A to Z are numbered from 0 to 25. Now C is the ciphertext and encryption is P plus 3. Okay. So if plain text is given to you, the quick brown fox. Now you can see what will be the third alphabet from T. That would be W. See the third alphabet from T. T is at the 19th position and 20, 21, 2. 19 plus 3 is 22. So corresponding to T, we have W. See in the PPT, you can see T is at 19th position and corresponding to 22, we have W. And H is at 7th position. So 7, 8, 9 and 10, you will get the K. E is at your 4th position. You will get 7, that is H. Similarly, you can go for others. T, X, L, then FN. Then you will retrieve E0, just like this. Q. Then for F is at, I'm in fifth position, so that will be I, O, then O for R, then X is A. Because if the alphabet finishes at 25, you can go move back to the first position. Fine. So now you will be applying the algorithm for some other text. So I'll show you that. Now let's apply the encryption algorithm and decryption algorithm. So I'm writing it here. Message, whatever is given to you is hello, and key is given to you as food. Hello and food. Fine. So let's do it. If I write the alphabets, so this is encryption side, and this would be your decryption side. So A, B, C, D, E, F, G, H, I, J, K, and 11, L, 12, M, 13, N, and 14, O. I think for this thing it is sufficient. So I won't be writing, or we can write O, P, Q, R, S, T, U, P, W, X, Y, Z, 15, 16, 17, 18, 19, 20, 21, 22. So I've written this thing, fine. So let's do it. Encryption says that is ciphertext is equal to E P plus key mod 26. This is the formula. Okay. So we are going to find the ciphertext for the given plain text. So plain text, you will divide it like this: H E L L O. Or you will write the L once because you are doing the same thing for second L. So we will not take the repeated characters. So H is at seventh position, I think. So formula is E of 7 plus 4 mod 26. So which is 11 mod 26. So it will give you 11 only. So it will give you 11 only. Now see the character at 11th position, that is L. Okay. Now for this encryption of E is at fourth position, 4 plus 4 mod 26, that is 8 mod 26. Now what is modulus operator, which gives you the remainder? So it will give you 8 only, and you will get 8th position, you have I, so you will write I. Then you have L, E of L is at which position? 11. 11 plus 4 mod 26. So 15 mod 26. I'll give you one example. So this is 15. When you divide it by 26, 26 zeros are 26. 26 zeros are 0. So you will get 15 as remainder. 26 zeros are 0. So you will get 15 as a remainder. This is called modulus operator. So this will give you 15. So at 15 we have P. Then you have O. E of O's position is 14. 14 plus 4 mod 26. That is 18 mod 26. That is equal to S. I think 18 only, and 18 is S for my, yes, it is S. So that means the ciphertext which will be equivalent of hello would be LI double PS, because for H it is L, for E it is I, for L it is P, and for another L it is P, so for O it is equal to S. I repeat again, you have to write first of all plain text. Then you will write the key. Now, for H, the formula is P plus K modulus 26. So your H is at 7th location and P is 4. 7 plus 4 is 11. 11 mod 26. So you will get 11 as remainder. Similarly, E is at 4th location. 4 plus 4, 8. And 8 mod 26 will give you 8. And at 8th, at 8th location, you have I. Right? Then for E, because then for L, we are finding the encryption because L is occurring twice. So you will take L once into the count. So L is at 11th position. 11 plus 4, 15. 15 mod 26 will return you 15 only. Then you have O. O is at 14th location. 14 plus 4 is 18. 18 mod 26 will give you 18 only and you will get S. Now decryption. How decryption is performed? You will get the decrypted text and you will have the, yes, plain text is equal to decryption of this ciphertext minus key mod 26. This is a formula. P of D, that is C minus K, and you will get the mod 26. Okay, or you may say perform the decryption. Now write down LIPS because here P is occurring twice. So value of L, D of C. L value is 11. 11 minus 4 mod 26. You will get 7 mod 26. So that is equal to H because at 7th position there is H. Then for I, D of I, D of I is 8. 8 minus 4 mod 26, which will give you 4 because 4 mod 26 is equal to 4 only. 4 mod 26 is equal to 4 only. At 4th location there is E. And for P we have description of PP is at 15, 15 minus 4 mod 26, that is 11 mod 26, 11 mod 26. So you will get 11 and at 11th position you have L. Then you have S. S is at 18th position. So D of 18 minus 4 mod 26, you will get 14 mod 26 as 14 only. So at 14th position you have hello. That means you have recovered the plain text from the given ciphertext using the Caesar cipher. So you will be getting HELO. And if one P is replaced with L, then another P will also be replaced with L. So you have got the plain text as HELLO. So this is the ciphertext algo which is used on both the encryption side and the decryption side. See here, now key has changed. It is now 15. Okay. So 7 plus 15, 22 mod 26, you will get 22. Okay. At 22 position, you have W. Then 4 plus 15 is 19. 19 mod 26. Same hello is there, but we have changed the key. 4 plus 15, that is 19. 19 modulus 26 is going to be 19. And at 19, you have which alphabet? That is T. Then 11 plus 15 is 26. 26 mod 26 would be 0. And you will get A here because your alphabet starts from 0. Right? Then 15 plus 4, 29 mod 26. You will get 3 as a remainder. You will get 3 as a remainder. So you will get B. Right? Now, let's do the decryption part. Now we have received the ciphertext as W, T, then you have A and D. Now 22 minus 26. W at this position 22. So 22 minus 15 because this is my key mod 26. So I will get 7 mod 26. I will get 7 mod 26. 7 mod 26 which is equal to 7 only, and I will get H because this is there. Now T. T is at 19th position. So 19 minus 5 mod 26. You will get 4 mod 26 which is equal to 4 only, and you will get E here because at 4th position there is E. Now next case. D of 0 because A is at 0th location minus 15 mod 26. Now what does happen? Here you will get minus 15 mod 26. Whenever this kind of cases are there, whenever you encounter the negative key, add 26 to it because alphabets are 26. So add 26 to it. Here you will get 11 mod 26 which is equal to 11 only, and at 11 you will find L. Next, here you will get 3. So D of 3 minus 15, that is minus 12. Minus 12 mod 26. You will get minus 12 plus 26 will be 14. Minus 12 plus 26 will be 14 because this is negative value. So add 26 to it. This is the rule for decryption, and you will get 14. At 14 you have O. So see, now you have retrieved the hello from larger key, that is 15. Now what is the benefit here? In previous example, hacker has to try the 4 combinations. Now he will try at least 15 to get it. But if you use 2500, 2600 kind of keys, then definitely the key space would be larger, and he has to make many more options or much effort in order to retrieve this text or guess this text. Fine, this is how Caesar ciphers are being used. Since see, if any attack happen on the Caesar cipher, the encryption and decryption algorithms are already known because you have given the formula. Second, only 25 keys because you are limited to 26 alphabets. So it is very easy to guess the Caesar cipher because only 25 key space is there, and it is very easy to make one program and to deploy. You just enter the plain text and you will get the ciphertext, or you will get put the ciphertext as an input and retrieve the plain text. Within a seconds you can do that. So language of plain text is known and easily recognizable. So these are your cons. And this is one screen that I want to show you. See, whenever you are applying key 1, see the transform text is -1, then -2, -3, -4, -6. At -6, see what is the key space when an attack happens. The hacker will try all the key spaces, and from these 25 key spaces, he will be able to get that the key is 6th one, where the text is being easily recognizable and readable. That is the quick brown fox. Fine. He has tried all the 25 keys and he is able to guess what is the exact text which was being sent. So this is not used these days because of these kind of things, because the attackers are more intelligent in today's world. So thank you for this lecture. And if you have any doubts or you want to ask any questions, you can send me on the WhatsApp. Thank you so much.